Hello everyone. Today we learn in chapter 7. In this chapter we will talk about the parallel computing pipeline and protection. The objective of this chapter, after your study, you will understand about the parallel computer system, and you can explain inside the parallel computer system, and you know about the limitation of processing data on parallel computer. And I will show you the C code that you have an experience to write a C code to measure the speed of your computer system, and to measure and compare with your friends about their speed in the computation speed. We have four topics for study today. First, we will talk about the single and multiprocessor, and then I show you the problem in multiprocessors. And the third, what is about works in the computer during a process. This is a detailed insight during you have a command, send it to the CPU and processing on the CPU. And finally, I show you the coding, the computer speed measurement on C language. Before we move to the detail, I give you about the information, some knowledge. We will talk about the SETI at Home project. What is the SETI at Home project? The SETI at Home project is a project from the Berkeley. They collect the signal from the space by use the radio telescope, like on the picture here. This is a large radio telescope capture signal from the space, and then they send the data to the member around the world. The member the member get the data from a software here. Member download a software and install to the computer. This software will connect to the server and get the data, and then after the works, example skin server and fee of the works, the program will run by use the fast Fourier transform to recognize and to check the signal and send the result back to the users. In the microprocessor technology, what is meaning in each word? The first word that is single processors. The single processor means a system contains only a processor that executes a sequence of instruction sets. Example, I have I have two instruction, two command. This is the first command here. First command, I suppose here. Second command. And here in this is a single core CPU. The single core CPU have cache memory and arithmetic logic unit for calculation in mathematics. The CPU process in each command by process the first command and then the second command after the first command complete. This is a processing in a single core CPU, single processors or single processor. You found a single processor on microcontroller today. Example here in Arduino. Arduino is a microprocessor have only a single processor. You run the processor by in each command from the line 1 until the end line. For the last processors on the computer, that is Intel Pentium. Intel Pentium. Intel Pentium in this is a Intel Pentium 1 from the 1993. The Pentium 1, this is a architecture of x86 run in the single processor. I support here, I have 4 command. The command is A assign 0, B assign C, A at 1, and C at A. From this is the first, second, third, and fourth. In each command, run by step from select the first command, run to CPU, and then the second, and third, and fourth run on the CPU. By ordering, this is a process on single processors. I think we compete in single processors. And now we will move to the detail about the hyperthread. Hyperthread relate to the multi-thread. Hyperthread. What is a hyperthread? In 2002, at the fourth generation of the Intel Pentium, Intel announced the techniques to improve the processing. Intel have 2 techniques. That is a hyperthreading technology and pipeline. For the pipeline, I will give you the detail in the chapter 8. And here, what is the hyperthread? Hyperthread is a hardware technology to speed the work or running more than one process run on the CPU at the same time. I think the hyperthread is like as a trademark from the Intel. This is the trademark from the Intel. But on the AMD, on another CPU maker called Thread, or the Thread. What is the hyperthread? The hyperthread doing right here. If you have a system in a single core, no thread doing like in this picture. By here, in this picture here, in this CPU run 2 thread 1 and thread 2. And here this is an operating system, OS. OS look at the CPU on the system. OS found the CPU is single core, single CPU. So that when you have a lot of command, OS will send command by order to run on CPU from the thread 1, thread 2 by order, not run in parallel. If you have Pentium 4, the Pentium 4 inside the CPU have a single processor. But the hyperthread management by looking outside from the operating system. The operating systems look at CPU, is found to CPU like as a parallel system, so that the CPU, the operating system organized by speed the work to run thread 1 on the first CPU and thread 2 on the second CPU. The operating system found to CPU by logical, not physical CPU, not real CPU in the logical CPU. The technique of the multi-thread will help by the concept will help to running more command at the same time. So the output to push, if you run in a single core, you have only a throughput. But when you are run on the thread technology, you have a double throughput. Inside the hyperthread is used a technique right here by the CPU have only one arithmetic logic unit, but some command example command I show you command here. This is a addition. The addition use the ALU, but here in this command for assignment, SSIGN, assignment assign value to a variables. Example, assign C to D, assign 0 to A is not processed on the ALU. So here the hypertext organized using the ALU by some command have about using arithmetic unit that is a process on ALU. Some command not process on ALU, process on another part outside ALU. So here when they organize like here, it will split the work to it will split from the single work to two works and run in the logical CPU like as you have a multi-core processor. Like when you buy a new CPU today, example you buy a Core i3 or i5. When you buy a Core i5 have a real core in 4-core CPU, but have a 4-thread. The 4-thread is like same concept, like as the hypertext here that I told you. So really in the CPU, in the operating system, while the system totally is 8-core CPU from the Core i5, but real physical CPU have only 4 CPU. Now we can conclude that the hyperthread is thread management by manage a single core CPU to use to speed the work by use the ALU and speed the process. Some process run on ALU, some process run outside ALU. Okay, now here I show you in this picture. Today the computer system we use in the multi-core system, like in this picture on the left hand side. Here the multi-core processor is means inside the CPU have more than core. This is a different from a single core. In this picture, CPU have a 2-core CPU, or 1, or 2, or 2. That is we call multi-core. The multi-core is doing like as the parallel processing. All CPU have a shared resource. That means in this CPU connect to the same memory. That is a shared memory. And here some high performance computers. The high performance computer example you are used in the workstation. In this is a desktop, most of desktop. And here this is a workstation. Or some server. The workstation and some server, the motherboards design the user can install more than one processor. Here in this, user can install 2 processors, CPU 1 and CPU 2. And it have a speed memory. This is a memory for this part, and this is a memory for this part. For this system, in the computer we call is SMP, semantic multiprocessing. And you can install the multi-core CPU to here, or you can install a single CPU to here. If you install single CPU to single CPU, your system will be the parallel processing, like as a multi-core. And I suppose if I install here to here, I have a both core CPU on SMP system. The architecture of the multi-core CPU have changed. Today, the CPU maker tried to make a high-speed CPU. They found some problem about the connection between the CPU to the graphic processor outside or graphic card. The connection cable design difficult and also have a cost for development. So they move the processor core by integrated to the chip inside the CPU core. The example I found that in Core i1, Core i3, Core i5, Core i7 on Intel, that is a have a processor, graphic processor inside the CPU, and also moreover in the processor chip M1, M2 from Apple that have integrated the storage solid state die to the chip. When you are integrated all of the in silicon chip to the chip, that is we call system on chip. System on chip mean you integrated CPU, you integrated the processor and storage to the chip. The advantage for making the SoC is reduce the production cost and also improve the speed, because the communication between CPU to CPU is very fast because it's a transfer inside the chip. Here in this picture, this is a multi-core. I suppose I install 2-core CPU to the SMP system. So here in this system, totally have a 4-core. Here in this, some system on SMP in this system difference by have a small memory, but here in this, most of SMP decided like this by install the CPU. You can put more than 2 CPU to the motherboards, depend on design by CPU maker or motherboard maker, and have a memory. Memory is shared to each CPU. That means some system decide to share the memory here, share the memory, or split the memory, depend on design. Now we found the limitation on the SMP system. Example, if you want to design a big computer system in the advanced parallel computer system, you can making a larger motherboard and install 100 CPU to the single motherboard, and also design the interface between the motherboard if you have being the motherboard to to make a big parallel computer system is very difficult. So today, the computer in really in large system, example in cloud computer, cloud computing, they bring the computer. Example, I bring the 5 desktop computer to share in the to connect in the network right here. To connect the network right here by the have a master computer connect to the network switch, and I have a 3 computer I assign like as a slave connect to the network switch. And network switch can use in the Wi-Fi or LAN interface in network switch. After that, I install a management software to here and software to here. The software manage the connection and communication between the computer inside the network or of the network here. And also, master sends some job to the slave, and then after slave calculated complete, it send the result back to the master. To management like here, we call the parallel processing in name cluster and distributed computing. This is a difference by this. If you bring the computer, connect the network in the same location, same building. Right here, all of computer in this is a server computer, like as a card, but this is not a card, it's really large. Here you have a lot of computer connected in the same location, same room. We call the cluster computing by being the high performance computing or workstation connected into the network, making cluster computing. And the designers, if bring the computer connect like as a safety at home project by being the computer connect and transfer the data via internet. This is a very large system outside from the buildings. Connect to home, connect between building to building, between country to country. We call the distributed computing or grid computing. Sometimes today we call cloud computer or cloud computer, cloud computing. This is the architecture right here. This is a cloud computing. By the difference from keywords, this is a cloud computing and distributed computing. Most of the distributed computing distribute the works. The works about the works like as a specific works work in the computer only, work in the calculation and do the research, do the scientific research. But the meaning of cloud computing is different. By the cloud computing, the type of the computers connected to the network internet, that is a difference by speed, difference by size. Here in this, mobile phone connect to the cloud, connect to the internet, a desktop computer connect to the internet, and a Mac desktop connect to the internet, and some laptop connect to the internet. This is a different platform connect to the internet. So here, like here, we call cloud computing. But if the same system and do the the same work. Example, I have a safety work distribute to the member. This is we call distributed computing. So now we will conclude that for here before move to the next slide. The first topic that I told you about the single and multiprocessor system. Here, the main point of a single, if you have a problem, they split to the small piece of work, piece of problem, and send it to one part to process on the CPU. But the multiprocessor system, if you have a problem or a lot of problem, they split to by operating system, split to the small part of problem and send to each CPU. And if you implement to the cloud or to the clusters, the CPU is different. The CPU represented by the computer. This is we call cluster computer. By the all of the CPU installed into the same location. And when we move to the LAN system, all of computer connected via internet, as is we call the distributed computing, and all of different computers by mobile phone, laptop, IoT connect in the internet and send the data and calculate the a lot of work in system we call cloud computing. So here this is a conclude for the different from single and multiprocessor system. Now we will move to the next topic about the problem of multiprocessors. When you connect a lot of computer to the network and you have a single work or two works or three work submit to the system. This is have a problem for computing that you must concern. Here, the problem have I think have a four problem. The first problem called race condition. The race condition is a problem of sharing memory by two or more processors connect and write the output to the same location. What is the race condition? Look at here in this picture. I suppose I have CPU A and CPU B connect to the same networks, shared network, and the location have a variable x. In this variable x, the sequence of the words doing like this. By I have a thread A and thread B. Suppose test A is CPU A, and thread B is CPU B. And this is a time from T0 to TT. The first step, the variable assign the number 17. The CPU A read the data have a 17. And then the next time, the CPU B read the same data 17. After that, the CPU A apply addition at 1 to the variable inside. This is a variable inside here. what is the variable inside the CPU? That is the cache memory. And then the small time, the CPU B do the same thing, 17 at 1 to 18. And then the CPU A writing back to the main memory. And certainly CPU B writing back the same data to the same location. So here in this is a CPU B and CPU A writing the same location have a problem because by the concept I want the CPU A read 17 and then write to the main memory, and then the CPU B read 18 to increase and write 19 to the memory. So the sequence not like this in this picture. This is a problem of the race condition. The next problem we call deadlock. Deadlock is memory lock and by two or more processors where some result from processing. Look at the picture here in this. The picture I give a description like this. By the first steps, here in this is a CPU, CPU, CPU. CPU 1, CPU 2, and CPU T. You have three CPU or three computer, or maybe sometimes called process, because inside the CPU you have operating system speed the work, and operating system call is the process. But now in the same thing, I change it from a process to CPU. If have a process named P1, P1 try to access the resource R1, R2, R2, R3, and R4 is resource. Resource is a memory location, or I/O, maybe resource, maybe mem or I/O. This is a resource in the computer. P1 try to access to R1, but the R1 used by P2. This is lock. LOCK, lock. And then P2 try to access R3, but R3 using by P3. This is lock. And also location of R2 is using by the P1 is locked, and also P2 is locked. The P3 try to access R2, so this is a waiting. So here, this part, when you look at this is a lock and waiting loop for P1, P2, and PT. So here in this problem like this, we call deadlock. Now the third problem on the parallel processing is starvation. Starvation is very low priority job waiting in a queue line, but doesn't have a chance to process on a CPU. This is occur right here in this. I suppose in this picture, This is a queue, priority queue line, and here this is a process inside a CPU. By I have some job, example job A, waiting here, and this job F, job C, job K, job B, job J. During job A waiting in a priority queue, and job F being to process in the CPU. After process complete, some job that is a very high priority. Example, top top uh, top queue. Top queue move to here, and job queue have a priority over job A. So job A waiting. If I suppose if I have more job, high priority job like job Q to do before job A. The job A have a starvation waiting for a long time until maybe the data or something lost. This is a problem on starvation. And the fourth problem classics on the parallel processing. This is a connection loss. And I told you at the information slide at the first slide about the safety at home project. When server from safety submit a work to member, some member turn off the computer during calculation, or some computer hang or network loss. So the data submit to the member may be lost some part of the data. So here in this is a problem when you submit a work to use to a member to each computer in the system. For the specifics of the work in the distribute in multiprocessor, when submit the works, we have send the works by the two type. That is a broadcast. Broadcast is the same data submit to each member. This is maybe computer here. This is a we call broadcast, like as a radio broadcast, like as an internet broadcast. And the next one is this scatter. If you have a large of data, split the works by less work, calculate to a computer. A yellow calculate to a computer. Right here, that is a scatter. By this is a piece of work and scattered to each computer. And here, correcting the job we call the greater. Greater bring or some parts of the work to join into same from the small job join into the large job or a job. So here in this is the join by have a summation. So here the 16 this is a come from 1 at 3, 1, 3, 5, and 7 at sum together. This is a half of 16. Now here in this topic, we talk about when you write a computer code and you're click running on your computer. What is in the process inside the CPU during run a code from your writing? And I suppose we run in the Intel CPU. I write a computer code here, program.c, by use command addition x at 1 x at 1, and I have a function main. After you write a computer code complete, you use the compiler GCC or Visual Studio to compile, and then you will have a.out file and some file.exe. When you click or type it on the console to run the program, in this code load to the memory, and here in this code, after load to memory, and it's being to each line, each location from the memory to process on the CPU. Here in this, the next page, I suppose I bring all of the code to memory, to here, to put on memory. This is my code to memory. After put the code to the memory, the CPU read the code by read in each location from memory to process on the CPU. The step of reading on the CPU by the basics have 3 steps. That is called the first step called fetch line as read data, and the second called decode. Decode is a piece of the work and sent to any part in the CPU to preparing for doing the job. And the third called execute. Execute do the data in each part to process as a command from fetch and decode. From the 3 steps, do like this. I suppose in the location 23 T023, this is a location. The CPU have a pointer to point at this location. That's called pointer name is PC. The PC abbreviation from the program counters. So the PC try to access in the next location. For here in this location read read from the memory, and after reading, this is write the data to instruction register has been write to the register inside the CPU. This is a process of fetch, and then they do the CPU do the decode. Decode speed the work by access to the location of the memory R1, R2, and R3. Set the access, and then the third step, the CPU do the execute by add all of the value, and here in this, I think add 1 to R1, R2, and writing back to the R3, and put the result to RT. So here R1 and R2 writing data, and here this is 45 at 78, and the result writing back to RT. No, oh sorry, I delete R1 and R2, R1 and R2, 30T at 45 is 78, writing back to the R3. This is an execution part. So here we can conclude that when you write a command on C language and you use a compiler to compile into the machine code, the machine code, when you click running, the machine code load into the memory, and then CPU lists in each location on the memory to do the process fetch, decode, execute to process. Here in this is a process inside the CPU. Now here in this activity 7.1, in this activity I show you the code inside the command. If you have a Windows system, you can open PowerShell in command line by press the window key and press R button. And then you type the command PowerShell. After that, you will have the program right here. And then you type the word hello, สวัสดี and write data to the file a.text. You will have file a.text. And show inside the file, use the command type to show the output right here. Now this is shown as a text data, but showing on the hexadecimal value or binary value, you can use the command format.hex. When you type format.hex, the output will show right here to show in the hexadecimal value. If I change from a.text to execution file, you can look at the hexadecimal value or machine code inside the file by use format.hex command from the Windows. Now the last topic, I show you a computer code to measure the speed of the computers. Here in this, I suppose we have two race car that have a compete in 10 kilometers race. A car A finish as 5 minutes, and then car B finish 6 minutes. How does calculate ratio performance between car A finish 5 minutes and car B 6 minutes? You can calculate the performance by using this equation. And I bring car A, division car B, and divide by car A. Here, 6 divided 5, this is a 1.2. And calculate to the percent, this is a difference 20%. So here, we write the code here. Example, the code assign a variable a, b, and have a loop while. This is a very large loop, counting calculation by addition a. I think a do here in 1 million loop. 1 million loop. So here in this is spending the time for making addition and multiplication. In this is a code example run on the online GDB. After you write this code complete, the code will show the computation speed from this line of the code. So the result of the code I show you when online together. And I have a code from the website. I write this code, apply this code on the JavaScript. JavaScript is a code for run in client. and then when you press the button here, the program you show the program will on the browser run calculate, and then it show message stop to show complete. During your after you click the run button, you must use the uh, stopwatch stopwatch to count the time, and then after it shows stop, you check the running time and write the result to here. This is a computing speed on the mobile phone and on the browsers on the browser. Finally, I will conclude uh, for this chapter. I think you understand single and single different single and multiprocessor system, and you know the SMP cluster problem on the compute on the parallel computing, that is a race condition, deadlock, and starvation, and also know the process inside the CPU during running a code fetch decode execute. Okay, thank you. See you when online.